All right, so a couple of examples for us to work through, just a couple of things. One of them I'm cleaning up from something I did earlier in a video. We're going to assume that we have a triangle ABC, and we're going to assume that the measure of angle CAB is greater than the measure of angle CBA. We will show that CB is greater than CA. That's the rough plan. Here's the way we go at it. Here's ray CB. There is some point B prime along here where CA is congruent to CA prime. There is a CB prime. There is some place. Maybe it's here, maybe it's here, maybe it's here. One of those is the actual location of B prime. And we'll see how this goes. So suppose B is B prime. And I suppose I should set this up better. There exists B prime on ray CB with CB prime equal to CA. And that's important because that's going to give you isosceles triangles, stuff like that. There are 3 cases. Case 1 is the case where B is B prime. We want to dismiss that quickly. Case 2 is the case where B prime is out here. We don't want that. Case 3 is this case. This is the one we want, because then CA is less than CB. That's the case we want. So this case is easy to dismiss. And it's easy to dismiss because if B is B prime, then CA is CB, and so these two angles are congruent, which they're not. So case 2. Oh, golly, case 2. Here's case 2. We have CB prime congruent to CA. That's what we got. So suppose C, then B prime. This is case 2. Then we know that the measure of angle CBA is greater than the measure of angle CB prime A by the exterior angle theorem applied to triangle ABB prime. So we file that away. Also, we note that the measure of angle B prime AC is greater than the measure of angle BAC by betweenness of rays. So now we start to string some things together. So the measure of angle CBA is greater than the measure of angle AB prime C. Well, wait a minute. AB prime C, that's this angle here. But because this is an isosceles triangle, that's congruent to this angle here, the measure of angle CAB prime. And we just figured out that that's bigger than the measure of angle BAC. But that means that this is bigger than that, and we know that that's a contradiction. And so case 2 fails. Case 1 fails, case 2 fails, and if we were writing it up formally, we would say, therefore it must be that B prime is between C and B, and so CA is less than CB as needed. One other thing I want to prove, that given some angle BAC, a point P lies on the angle bisector of angle BAC if and only if the distance from P to line AB equals the distance from P to line AC. Remember, this goes two ways. We have to prove both ends of the conditional. So we'll go this way first. We will assume that P lies on the angle bisector, and we will show that the distances to those two lines are the same. So for our arguments, and I won't write it out formally in this video, let's let the feet of those perpendiculars be D and E, because we're measuring distances from a point to a line, and the way we measure distance from a point to a line is along a perpendicular. So D and E are the feet of the perpendiculars from P to line AB and line AC respectively. So going this way, we know that angle PDA and angle PEA are right because D and E are feet of perpendiculars, and angle PDA is congruent to angle PEA because all right angles are congruent. Also, angle PAD is congruent to angle PAE because AP is an angle bisector. So triangle PAD is congruent to triangle PAE by angle side. And PD is congruent to PE by correspondence. So then we go the other way. You have some angle BAC, and you have some point P such that the distances to lines AB and AE are the same, and you want to prove that ray AP is an angle bisector. So because the distances from P to AB and AC are equal, PD is congruent to PE, and angle PDA and angle PEA are right. Thus, triangle PDA is congruent to triangle PEA by hypotenuse leg. So angle PAD is congruent to angle PAE by correspondence, and AP is an angle bisector. Done. So now we have a property of points on an angle bisector that high school geometry students use all the time. Great.